sometimes north of you and sometimes south of you during the year. So you've got to have a symmetrical object. And people like my father would use a stick. You can use a rectangle, but that has some features. Anyway, I did the analysis on the gnome, the metal post. And the reason it's so big around, yeah, it's like that, is to get enough pixels. Anyway, it's fun. I mean, you could tow a truck with it, okay? And it screws into the base, and it's all very solid. If it had come loose on the way to Mars and rattled around on the billion-dollar electronics, it would have been solid. It didn't, it's all good. But with that said, last spring, somebody sent me this picture. And then I realized it was April 1st. Kids with your Photoshop.
You crazy kid.
It was a full comedy beat where my life was passing before my That's not how it's attached. Now, speaking of Mars, this is the Hellas Basin, which is a crater on Mars. It's been there for a few billion years. And it's generally agreed now, based on radar data from orbiting Mars spacecraft orbiting Mars, that under about 10 meters of rock, I mean like from the floor to the ceiling maybe, is a glacier, a water-ice glacier on Mars. Now, my friends, if there's that much water there now, there used to be water flowing all over Mars. Maybe there used to be life. Yes, microbes, Marscrobes, doing Marscrobial things. If we could go there with the next spacecraft and sniff around, maybe we would find evidence of life. Maybe we would even find something still alive. And my friends, if that happens, it will, dare I say it, change the world. It will be like Copernicus or Galileo or one of these guys, except it will not have been done by an individual, it would have been done by a society who thought it would be an interesting and charming thing to explore another world, just to learn about the universe and our place in it. My friends, you may live through a world-changing event in the next decade or so. So with that said, you are all in the space generation, and when life is discovered on Mars, you will go, I saw it coming. But you are also all members of what I like to call the climate generation. Now, in order to be a member of the climate generation, you have to be born after the 23rd of June, 1988.
Yeah.
And along with that, my grad student friends, like, just watch out. Here is these are famous pair of pictures. This is the solid glacier in the Patagonia region of South America and Argentina in 1928. And it's a glacier, of solid glacier. That's where they got the idea for the name. But if you go there today, it's not a glacier. It's a sandy, cold place. A solid sandy cold place, not as compelling. And you guys all lived through this sort of thing. It's gotten, of course, much more rapid. These two pictures are archetypal, they're famous. I just want to refresh everybody. And this is what I call not the joy of discovery, but the heartbreak of discovery. Well, yeah. So, I know there are going to be people in a room this big who are skeptical of climate change. Sort of arms akimbo about it. This is a hoax. Oh, you crazy people. They'll won a Nobel Prize. Yeah. But if you're skeptical of climate change, I strongly encourage you to do what I did. Go to the Ice Core Lab in Glendale, Colorado. Not Glendale, California, Glendale, Colorado. And when you go into the Ice Core Lab, they have these cylinders of ice, about this big around, and 10 meters long, 30 feet long. And they're in these aluminum foil tubes, all labeled and labeled and labeled and cataloged and carefully stored and labeled and cataloged. And it's very cold there. It's 37 below, which is Celsius, which is like 30-something, 34 below apparently, because they frost. Anyway, so I asked the head guy, Todd Hinckley, Dr. Hinckley, why did you pick minus 37 Celsius? Was that in order to balance the eutectic, the evaporation, sublimation of the samples with the chemical analysis? No, Bill, we didn't pick it. We grabbed the thermostat and turned it all the way down. As cold as it will go. Dude. But if you look at the ice cores, any one of them, these are taken from Greenland, Siberia, Antarctica, various places. If you look at the ice carefully, you take it to the warm room, by the way. And I got to say, it does feel warmer. You take off, one of the 3 pairs of mittens. You can count layers of ice, layers of snow. I mean, it's much, much easier than counting tree rings. Much easier. Because they're about that far apart, like 10 centimeters apart. And you can see where spring started, the snow started falling. You can see where the winds from Asia blew dust there. You can see when it got colder, when it got warmer. And so what we do, we take, you can see there's the dust. We can take these thin slices. And between the tines of ancient snowflakes are these little bubbles, these tiny bubbles captured in the snowflakes. There they are. And so you're looking directly at ancient atmosphere. Now, there will be some bubbling up, but the argon doesn't bubble up as fast as the oxygen, and these guys have all these kooky methods for accounting for that. And they can measure almost perfectly the temperature of the sea surface that made the snow that fell in these places. All you got to do is count neutrons. Well, if you have a mass spectrometer and you're diligent and careful, apparently it ain't that difficult. I say ain't for comedic effect. Isn't that difficult? And so they have temperature data from the U.S. Navy, the British Navy, that go back hundreds of years that are very accurate. These old thermometers from the 19th century still work fine. And you can then bootstrap your way, say these data are accurate, then you can extrapolate way into the past, as much as 400,000 years, and the world is getting warmer. When the sea surface is warm, more neutrons evaporate with the oxygen and the hydrogen to a lesser extent, and when the sea surface is cool, fewer of the heavy oxygen atoms evaporate. And this is becoming apparent to everybody in the world, especially in Arctic regions. I was on an airplane in September, and this is Greenland. Well, it's a picture of Greenland. It's called fitting. And I think if you look carefully, this room is the light's kind of bright up there, but you can see where where ice is flowing into the North Atlantic. And if you look carefully, I'll do this for you. If you look carefully, you can see that it's kind of recent that this ice wall collapsed not that long ago. So the world is getting warmer, and you see it in the ice. The ice is so compelling. You see it in the pollen. You see it in the dust. But the ice is where it starts. Now, this is a picture from the crater rim of Mount St. Helens. Has anybody been to Mount St. Helens? Right on! Did you go to the top? You did? Yeah. So you know, the reason everybody's lying down is because right at that gray edge, that this gravel, it's called scree in Scandinavia, right there is a crater. If you stand there, what? It's the last thing that's it. This is human nature. You just take it all over. And the stuff is it's ball bearing. It's very slippery. Subsequent, take a rope picture. It'd be cool to get right over it.